Welcome back to my channel. So today I'm posting a revision video on chemical bonding with an idea of helping you revise for the September exams. So this is basically on demand of so many of my students who feel chemical bonding is a very overwhelming chapter. So it would really help if somebody helps to outline the topics. And I have attempted to help you revise this in the sequence of NCERT. So I've just chosen the topics in sequence of NCERT and revised all the topics exactly the way given in NCERT. So that helps you for a quick revision of the chapter. I'll be going through it fast, and wherever you want to repeat a topic, you can pause, go through it again. And I will also try, if possible, to post some important questions based on this video in the next video, right? So let us proceed. Watch it carefully till the end. And if you like it, share with others and like and subscribe. Let us proceed. We're going to start with the chapter Chemical Bond, one of the overwhelming chapters of this class. And remember, this is a very high yield chapter. This is going to help you prepare for your school exams as well as give you a quick basic review of the 90% component that is covered for your JEE as well as NEET exams. So if you just catch up on these topics and then prepare with multiple choice questions, you'll be good to go. And remember, majority of these papers, JEE as well as NEET, are around the NCERT concepts. Everything that we teach for competitive edge beyond NCERT caters to just 2-3% of the exam questions. Majority relates to NCERT. So if the average and above average students who have a less capacity to learn, now they can benefit a lot if you just focus on NCERT concepts and you know them well with practice, not just rote cramming, but actually understanding the topics. So I'll try to explain the topics to you. Let us go ahead. All the best. Listen very carefully. Practice. If you want to make notes, whatever you want to do, just give it a quick review. Keep your notes copy in front of you and you can highlight the important points. Let us go ahead. So to start with, what is a chemical bond? You already know a bond is a force of attraction which holds various constituents, that is atoms, molecule, or ions together in a chemical species, right? Now, the mistake that you will do if you're asked this question, what is a chemical bond? And you start your definition with it is a bond which holds various constituents, or it is a bond formed between different constituents. It goes wrong because you're basically asked what is the meaning of the word bond. So what you have to be careful about, you have to use it is a force of attraction, right? And now, why an atom combines to form a molecule? So basically, why do atoms combine to form molecules? This basic reason for atoms to combine to form molecules is to attain stability. And how do they attain stability? By decreasing the energy content of the system and by attaining octet configuration. Now, how by decreasing energy content of the system? You have to remember that attractive forces always lead to decrease in energy of the system. Decrease in energy, and repulsive forces always increase energy of the system. And this is applicable in everyday life also. Attractive forces, friendships, give you peace, support system, low energy, stability. Whereas repulsive forces like enmity, jealousy, envy, any such kind of negative emotion makes you restless, unstable, and increases your energy, right? So this is basically a life lesson that even atoms use. And second point is by attaining octet, because each atom has a basic tendency to have a set of 8 electrons in the outermost shell. So all atoms combine to form molecules except noble gases. Why do noble gases not form? Because they already have a complete octet. Helium, neon, argon, krypton, xenon, radon, they do not have a tendency to combine because they have a stable octet. Although we do have some compounds formed from noble gases also, but they are one such group of the periodic table which do not have or have negligible tendency to form bonds or compounds because they already have a satisfied complete octet. Now, what were the theories on the formation of molecules? In this chapter, we are going to cover how various scientists develop the various theories. None of the theories is discarded. All the theories are accepted, but each of the theory has some limitations. It helps to explain certain aspects, but none of the theories is complete to explain the various aspects of bond formation. So we are going to follow the journey of various theories, and the theories that we are going to discuss is the empirical approach, which is mostly based on observation. This was given by Cossell and Lewis. The Cossell-Lewis approach in 1916. After that, we'll be talking about the Vesiper theory. That is the valence shell electron pair repulsion theory, which was proposed in 1940. The years are not very important, but then you never know. Anything that is quoted in NCERT can be asked, right? And then we had the quantum approach. Under the quantum approach, we had the VBT, the valence bond theory, 1927, and VBT as well as the Vesiper theory. These two theories were combined together to explain shapes and geometries of molecules. Please, it is very important, children, understand to have a link of the chapters, not just rote cramming the topics. These theories, you can see, were given very close to each other. So VBT explained certain aspects, and then when Vesiper came up, combining both these theories, we could explain shapes and geometries of molecules. And then comes up the MOT, the molecular orbital theory, which is going to be the last theory in this chapter, which will explain the limitations of other theories. So what are the types of chemical bonds that we're going to study in this chapter? Ionic bond, covalent bond, and metallic bond. And then we also have coordinate bonds. Coordinate bonds where they differ only in the process of formation, but after formation, they behave like covalent bonds only. So polar covalent bonds and non-polar covalent bonds, we have two types of covalent bonds, which we are going to describe under the topic polarity. Cossell-Lewis approach to chemical bonding was given by these two scientists, Cossell and Lewis. Cossell and G. N. Lewis explained the chemical bond in terms of electrons. This is the key point. They talked about electronic exchange, either give or transfer or mutually share. So using electrons, various theories were proposed. They pictured atoms in terms of positively charged kernel and outer shell electrons that could accommodate maximum of 8 electrons. So Cossell and Lewis' concept of bond formation was based on the fact that an atom has a positively charged center, which was the nucleus, right? They did not use the word nucleus to describe this. These terms were not yet used, but they pictured terms in terms of a positively charged kernel. What is a kernel? I'll explain. So let us suppose I'm talking about sodium metal, whose configuration in simplest terms is 281. So there are 3 shells, according to atomic structure, the KLM shell, where the K and L shell, these are called the core shells. And the last shell, whichever is the last shell, will be called as the valence shell, right? So this is 2 electrons. Here, let us say there are 8 electrons and 1 electron. So the nucleus plus the core electrons, this is going to be called as the kernel. And this shell is the valence shell. So that means I can also define kernel as the nucleus plus core electrons, or I can also define it as considering the entire atom minus the valence electrons. And since we are not including the valence electrons in a kernel, kernel is going to be positively charged. Why? Because kernel means I'm talking about 11 protons, part of the nucleus, and I'm talking about only 10 electrons because I'm not including the valence electron. So obviously the kernel, this is the kernel, has to be positively charged. I hope you understand. So Cossell and Lewis pictured atom in terms of positively charged kernels, and outer shell electrons that could accommodate a maximum of 8 electrons. Now, what is a kernel? I've already discussed with you. Kernel means nucleus plus inner shell electrons, or it also means atom minus valence electrons. Valence electrons are the outermost electrons, and all other shells put together will make the core electrons. So even if an atom has these many shells, so this much is going to be the kernel, and this is going to be the valence shell. So let us proceed further. What is octet rule? According to octet rule, octet means 8. Atoms can combine either by transfer, very important, transfer of valence electrons from one atom to another, or by mutual sharing of valence electrons in order to have an 8 electron in the valence shell. So what is the basic requirement for every atom? Like, let us say I'm talking about hydrogen and chlorine. This is 1 electron and this has 7 electrons. Like this. I'm showing different symbols just to be able to differentiate between two different atoms. This one is short of 1. This is also short of 1 because hydrogen wants to complete duplex. This wants to complete octet. What do? They mutually share these electrons such that each now is going to have an advantage of the electrons of the other. This is called mutual sharing of electrons. This is going to form a covalent bond. Mutual sharing, each contributing 1, and this pair is now a property of both. Or if I was talking about something like sodium chloride, chloride having 7 electrons and sodium having 1 electron in the outermost shell. The configuration of sodium being 281, that of chlorine being 287. So what happens? This is going to give its electron to chlorine. This will be left with complete octet, and this receives this. It also gets a complete octet in the valence shell. So what is this? This is complete transference of electron from one to other. Hence, complete transference means we are talking about an ionic bond, and mutual sharing means we are talking about a covalent bond. Very simple to remember. You've been doing this till 9th standard also. Now, what does octet rule show? Let us say we are talking about chlorine, 2 chlorines having 7 electrons in their valence shell, and they mutually share this. So when they mutually share, now each is going to have 8 in its outermost shell. So this is mutual sharing of 1 electron between 2 chlorine molecules, 287, 287. Which means a covalent bond can be formed between dissimilar atoms or similar atoms. Now, what are Lewis symbols? The scientist Lewis proposed a symbol to how to explain on paper formation of molecules. For that, we will be using Lewis symbols, and Lewis symbols will involve outer shell electrons only. Since outer shell electrons are the ones which take part in chemical combination, core electrons do not participate in bond formation. So he suggested, why do core electrons not take part in bond formation? Because they are more protected. Inner shell electrons are well protected, and these are not involved in bond formation. So Lewis, an American scientist, introduced simple notations to represent valence electrons, and these notations are called Lewis symbols. These are Lewis symbols. Now, what do you have to remember about Lewis symbols or dots? Simply write the symbol of the element. You simply have to write the symbol of the element and show the valence electrons around it. Okay, let us say lithium. The configuration of lithium, Z is 3. That means configuration is 2 and 1. So I have written lithium. Lithium, writing the symbol means I'm showing the nucleus plus its core electrons. And I've put the valence electron as a dot. Similarly, beryllium, the configuration is 2, 2, since Z is 4. So the 2 valence electrons will be shown along with the symbol. Boron, it's 2, 5. So Z is 5 for boron, which means it is going to be 2 and 3, so 3, and so on. This is how we are going to show. And argon, for which we have 8 valence electrons, so 8 dots have been made. This is the Lewis symbol for elements. Remember, Lewis symbol of elements means show the symbol of the element and write the valence electrons around it. Number of dots around the symbol represent number of valence electrons. Next, we have steps to write down Lewis dot structures. So we determine the total number of valence electrons. For anions, each negative charge would mean add 1 electron, and then figure out how many octet electrons a molecule should have using the octet rule. So I will directly express this in the form of an example instead of explaining through the words. You can pause and read the words if you wish, but I'll explain directly through examples. How to make Lewis dot structures of molecules. Now, to make Lewis dot structure of carbon monoxide, the first thing is I'm going to count the valence electrons. What are the valence electrons with carbon? Carbon atomic number Z is 6, configuration is 2,4. Oxygen Z is 8, configuration is 2,6, which means the valence electrons when added together for the two molecules, for the two atoms will become 10. So once the valence electrons are counted, now I'll be drawing this skeletal structure of carbon monoxide. How to draw the skeletal structure? Choose the two atoms and simply connect them by a covalent bond. You can use a line to show this, or you can show a pair of electrons like this, because one bond means 2 electrons. The ideal way is this, because we're talking about Lewis dot structure, but even this is accepted if instead of these dots, you draw a line. What do we do now? We will choose the more electronegative atom to complete its octet first. Complete the octet of the more electronegative atom first. One bond was already there. That means 2 electrons were already there. I put 6 more around this oxygen to complete its octet. And I have used 8 in the process, but the total electrons we had were 10. 6 plus 4, 10. 10 electrons we had in all. Right? So we are left with 2. These 2 electrons will be put here as lone pairs on the central atom. Now the central atom carbon has 2 and 2, 4 electrons. I need 4 more. 4 more to complete the octet of carbon, but already we've used all the electrons of the pool. How? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 all gone. So what are we going to do? We are going to request this oxygen to share its 2 electrons here to complete the octet of carbon as well. So now what is the net outcome? This oxygen still has its octet complete. Oxygen has nothing to lose, but now even the carbon also gets its octet complete. Fine. So I just repeat in a quick sequence. We wrote carbon and oxygen. We first completed the octet of the more electronegative atom, assuming the less electronegative to be the central atom. Already 8 gone. I put 2 more on carbon. Why? Because I had a total of 10 electrons as sum total of valence electrons of carbon and oxygen. Now, I need to complete the octet of carbon. For this, these 2 will be shared by oxygen such that octet of both is complete. So what is the overall structure? I can draw the structure like this. 3 bonds between carbon and oxygen, 1 unshared pair on each called as lone pair. We move on to the next. This is the structure of carbon monoxide. Okay. Now, Lewis dot structure of carbonate ion. Before we see here, I'll just help you quickly. The valence electrons of carbon 4. Why? Because the configuration is 2, 4, since Z for carbon is 6. For oxygen, Z is 8. The configuration is 2 and 6. So for each oxygen 6, but we have 3 oxygens into 3. And to this, I'm going to add 2 more electrons. Why? Because of this negative charge. So the total becomes 4 plus 6 into 3, 18. and plus 2. So we have 24 electrons as the valence electrons. So what are we going to do? I'm going to put carbon, and 3 atoms will be joined by a single bond. Single bond means one pair of electrons. You can either write just the dots or you can make these bonds. And now I'm going to complete octet of all these. So already each oxygen is having 2 electrons. I'm putting 6 on each mole. So when I do this, around each oxygen, I can see 8 electrons. That makes a total of 8 into 3, 24. So 24 electrons in all have already been used up. But carbon octet is still incomplete. Carbon still needs 2 electrons. So what will we do? Any one of the oxygens, any one of the 3 oxygens is going to share one of its electron pair with carbon. So what is the result now? Each of these is going to have, each oxygen is having its octet complete like this. Each oxygen has its octet complete, and carbon also has its octet complete. So this is the structure of carbonate ion, CO3, 2 negative ion. So now, number of valence electrons were 22. We added 2 due to the negative charge, 24. And then simply put the central atom as carbon because it's less electronegative, and complete the dots as explained. Right? Now, Lewis dot structure of some molecules just represented. You can practice drawing these. These are the ones given in NCERT. Okay. So next important point, if you get a question on draw the Lewis dot structure of any molecule, your answer is incomplete if you're not putting formal charges, right? So how will you put formal charges on that? For formal charge of an atom in any polyatomic molecule or ion, it is going to be basically, what is formal charge? It is the difference between number of valence electrons of that atom in isolated or free state and number of electrons assigned to the atom in the Lewis structure. It's basically the net outcome after give and take. Okay, so let us see how do we calculate the formal charge. Total number of valency electrons in the free atom minus total number of non-bonded, that is lone pair of electrons. We are not counting pairs, we are counting electrons, minus total number of bonded pair of electrons. This is how we calculate the formal charge. And we take up an example of ozone molecule. Now, let us do it this way. I'll first help you to draw the Lewis structure of ozone molecule. How do we draw the Lewis structure of ozone molecule? We've just learned this is 6 valence with each oxygen into 3 is equal to 18. I draw O, O, and O. You can draw O like this, or you can draw 3 oxygens in a straight line. Why? Because Lewis dot structures give us no idea of the shape or geometry of the molecule. They give us no idea of shape and geometry, so we can just write them in any way. I can write them in a straight line as well. What is the next step? I put one line to connect the various atoms, or I could have written dots. And now, complete the octet of the surrounding atoms first. First, the surrounding atoms. Generally, what do we do? More electronegative atom is to be taken as the central atom. But here all 3 are seen. So place any one oxygen in the center. Fine. And what do you do next? Now, we've already used how many? I have used, if you check this, 8 electrons shared here and 8 here. So already 16 gone. We are left with 2. So what will we do? We will put these 2 left electrons out of this pool. 16 already used, 2 were left. We place them on the central atom. If nothing is left here, no electrons will go on the central atom. And now, if you see, the central oxygen has only 6 electrons, right? It still needs 2. So just rub 2 electrons from any of these and convert to a double bond. Fine. So this becomes the structure of ozone. The central atom now also has its octet completed. Is it right? So this is how we draw the dot structure of ozone. This is the final structure. Now, how are we going to find the formal charges? Let us say I want to find out formal charge on this. So what is the formula that we have just talked about? The formula, okay, let us start with one. The formal charge formula says whatever oxygen we are going to try, 6 is the valence electrons in original oxygen because Z is 8. 2, 6 is the configuration. So 6 valence electrons this oxygen has minus non-bonded electrons. Not pairs. We have to find out non-bonded electrons. So non-bonded electrons are 4. So I do 6 minus 4 minus half of the bonded electrons. What are the bonded electrons? These are the bonded electrons. 2 bonds means 4 electrons. So I put it as 6 minus 4 for this, and for this I put it here. So when you solve this, 6 minus 4 minus 2, what do you get? 0. So what is the formal charge on this oxygen? 0. First oxygen, 0. We need not write anything when it is 0. So what are we going to do? You can pause this and check yourself, children, if you're able to manage it or not. Again, these are the valence electrons in oxygen. These are 2. Which 2? These 2. These 2 I have written here. And which are these 6? 1, 2, and 3 bonds. 3 bonds around this oxygen means 6 electrons. So when you solve, you're going to get +1. And similarly, formal charge on oxygen, 6 minus half of 2, you get it as -1. Yeah, how 6? This is valence electrons in the original atom. Valence electrons will remain the same. That's a part of the original atom. This 6 comes from 2, 4, and 6. Unshared, non-bonded electron pairs, minus half of this 2. So this comes out to be total of -1. This is how we calculate the formal charge. So you're going to write it as this is going to be, how are you going to show these charges? This is 0, so no need to write anything. Here you'll write +1, here you'll write -1. And also remember children, when you're writing these charges, must check that overall, after putting the charges, the molecule should have the same charge as in the original structure. Like ozone is a neutral molecule, so +1, -1 is also making the net charge on the molecule as 0. So this will help you to find out your own mistake. Okay, carbonate ion. Again, let us first start by trying to draw the Lewis dot structure ourselves. So we did discuss in the early part of this. This is the Lewis dot structure of carbonate ion. We did draw this in this same video. Now, how to decide the formal charges? For this, carbon is going to be 6 minus 4 minus half of 2 bonds means 4 electrons, right? So this is 6 minus 4 minus 2, that's 0. So the formal charge on this oxygen is going to be 0. We don't even need to write. This oxygen is going to have 6 minus half of 2. Why 6? This 6, 2, 4, and 6, right? This is the valence electrons in oxygen, and this is what is giving you the 2 electrons. When you solve this, you're going to get 6 minus 6, 0, and this is -1, right? So this gets -1 formal charge. This has the same surrounding, 1 bond and 3 unshared pairs. So this is also going to get -1, right? So total -1 and -1 on each atom means the net charge becomes -2. So that's how you're going to confirm, right? So this is 0. Carbon is 0. How did we find on carbon? Carbon valence electrons are 4. and we have no unshared pair. There is no unshared pair on this carbon. So this is 0, right? Minus half of 8. Why 8? 2, 4, 6, and 8. So these 8, finally we have 0 charge. This is 0, this is 0, this is minus 1, and minus 1, total charge is minus 2. Nitrite ion. I've drawn the nitrite ion here, but let me first tell you how are we going to try to draw the Lewis-Dot structure for nitrite ion. How do we draw the Lewis-Dot structure for nitrite ion? Let us draw first the valence electrons. The valence electrons 5 for nitrogen. Why? Because for nitrogen Z is 7, the configuration is 2, 5, 5 plus 6 into 2, 12, and plus 1 due to the negative charge. This is going to make it 18 electrons. So which atom is the central atom now? The central atom has to be nitrogen. And we put 2 oxygens. We can put them anywhere on the side or angular or anywhere, because this doesn't tell us about shape and geometry. Remember, Lewis-Dot formula tells us nothing about shape and geometry. This can even be asked as a limitation or a multiple choice question. Okay. So irrespective of nitrogen contributed how much, oxygen contributed how much, we're not to bother. This is the family pool. From here, we have to give electrons. How do we give electrons? The electrons are first to be given to the more electronegative atoms. I've put 6 because I've shown 2, 6 more, 8 gone. Similarly, 6 here, 2 are already there, 8 gone. This is complete, 16 electrons gone. We are left with 2, so I put 2 here. And the octet of nitrogen is still not complete. It has only 6. So what do? Any one oxygen out of the 2 will be giving 1 pair to nitrogen. And you will observe now the octet of each atom is complete. This is complete, this is complete, and this is also complete. This is nitrite ion, right? So this is the structure of nitrite ion. And how do we predict the formal charges? Now, the formal charge of the first one, you can pause, children, and try yourself to check whether you understood or not. So let us check first for nitrogen, 5 minus 2 minus half of 6. What did we do here? 5 is the valence electron in nitrogen. This 2 is because of this. And 3 bonds around nitrogen means 6 electrons. So it comes out to be 0. Similarly, for formal charge on oxygen, double bonded oxygen is going to be 6. 6 is valence electrons. 4, you can see unshared electrons. 2 and 2, 4 put here, right? And minus half of, just give it a thought, half of what? Half of 4. Why? Because we can see 2 bonds around this oxygen, which means 4 electrons. So we get it as 0. No charge on this. Single bonded oxygen atom, 6 minus half of 2. It is minus 1. So what are the formal charges? The formal charges are minus 1, 0, and 0, which means the net charge is this. Minus 1 plus 0 plus 0. The net charge is written here. So this is how we make the Lewis-Dot structures. This is ozone, nitrite ion. Now this is azide ion. Let us try. This is not given in NCERT, but let us try making azide ion. This is 5 into 3, 15 plus 1. That makes it 16 electrons. I put N, N, and N. I join these first with a single bond. Complete the octet of the surrounding atoms. All 16 gone, which means nothing is left for the central atom as lone pair. What next? I'm going to simply ask either each one to share 1 pair so that the octet of the central atom is complete. Or what else could we have done? Nitrogen, nitrogen, and the octets were complete. Any one out of the 2 could have shared their 2 pairs. Any one out of the 2, say this nitrogen shares its 2 pairs. So what is the purpose? Purpose is to let nitrogen have its octet getting completed. It can be done in either of the two ways. Later on, we'll understand these two are resonating structures of azide. Is it right? So you can see each of these nitrogens in both the structure have their octet completed. That's all. Fine. So now what are we going to do? We are going to look for formal charges in each case. Let us say in this case, let us look for the central nitrogen. How do we go for central nitrogen? The valence electrons 5 minus 0, no non-bonded electron, minus half of 8. Why 8? I can see 4 bonds around this central atom. So 8. So this is going to make a +1 charge on this nitrogen. Similarly, if I calculate for this nitrogen, it's going to be 5 minus non-bonded 4 minus half of 4. Why? There are 2 electrons here, 2 and 2, 4, this 4. And these 4 have been written here. So when you solve, you're going to get this as what charge? 5 minus 4 minus 2. So your net answer is -1. And this nitrogen has the same surrounding as this terminal nitrogen. This also gets -1. And what you're going to check, the total molecule has a net charge of -1, which justifies this charge. Clear? If you wanted to draw this structure, then how would you check the formal charge? 5 minus 2 minus half of 6, which is 3. So this is going to get 0. Similarly, when you solve this, it's 5 minus 0 minus half of 8. You get it as +1. And when you solve this one, it's 5 minus 6 minus half of 2. You get this as -2. And what you're going to check finally is that net total of these 3 charges will come out to be -1, which is the same charge as the charge on the species. I hope this is clear and understood. Yeah, just follow the method, children. Don't cram, don't learn various structures, follow the method. And once you've done it well, it should not take you more than 30 seconds to draw a structure and to write its formal charge. Please put in time to understand the methods than just cramming.